So once in a while when you download data from the internet, you'll get data that lacks spatial reference information. And what that means is that this geographic data set doesn't have the associated projection and kind of spatial reference that's necessary for ArcMap to figure out where on Earth this data is located. Not only that, spatial reference information, in addition to the, where is this? Is Indiana where Indiana should be located, or is it where Germany is, or what? It also, spatial reference information tells the software how big that data is, how much area it covers. So without spatial reference information, for instance, the state of Indiana could cover only the area of a city block, or it could cover the entire globe. The software doesn't know. And so when you get such a data layer, you'll end up, I'm going to add one here that I know lacks the spatial reference information, you'll end up typically getting an error message that looks like this. The following data sources you added are missing spatial reference information. The data can be drawn in ArcMap but cannot be projected. So what that means is you get the data, it'll show up, it'll look okay, but if you add data that does have a projection on top of it, things aren't necessarily correct. And the software here is guessing that Indiana is located here, but we don't know if that's correct. So what we need to do is make sure that the correct spatial reference information is associated with the data. And to do that, what we have to do is figure out what that spatial reference information is. Now, we learned about metadata a little bit in the first lab exercise. And so what you have to do to find out whether this unprojected or data that's lacking spatial reference, you have to figure out what that spatial reference is. Luckily, most data actually come along with a HTML file. It can be a text file. It can be something like that tell you what the spatial data are. So what the spatial reference information are. So in the case of this county data, if we double click it, it's an HTML file. And in this case, now this is different data than the one that we're using, there's a whole bunch of information here, and some of it we don't really care about. And luckily there's a link here, spatial reference information. If we click it, it actually scrolls way down the page to where spatial reference information is included. And we can see here that there is a grid coordinate system called Universal Transverse Mercator. Now this abbreviates typically down to UTM. And UTM is a type of projection. We don't have to get into that too much, but it divides the world into 60 different zones based on longitude, and Indiana ends up being in zone number 16. And so every projection also has a associated datum, which basically tells it where the origin of the coordinate system is. And in this case, it's one called the North American Datum of 1983. That's NAD. It's abbreviated to. And this is pretty much treated exactly the same way as another one that's called WGS 1984, or the World Geodetic Survey of 1984. I'm just providing you this information so you know, because it's going to be something that you probably run into at some point in the near future. So let's assume that the data that we have in ArcMap right now, this CO18_D00, came with the metadata that I'm displaying here, even though it didn't. I happen to know that this data is in UTM zone 16 because of some other information that I'm not showing you, but your data should come with metadata. If it doesn't come with metadata, such as in this case with the data that I have currently in ArcMap, you can often go to the source website and find a page that tells you, all data on this website are in this projection and coordinate system. That's the case with this particular data, so we don't have to worry about it, and it said UTM zone 16. So now that the data, we want to make sure the data is added in ArcMap, we want to use this thing called the Arc Toolbox. And if you click on it, it'll take a minute and open up this toolbox shows up, right? And because the Arc Toolbox actually organizes tools in a hierarchy here. So if you go into some of these categories, there's all sorts of different subcategories, and it's a way of keeping things organized. You can also search for things based on their name in an index, and you can search for things by entering in words that are associated with them. just as a heads up, if you run into something and you want to see how to do it, you can often find it using those tools. But what we want to do is give this data we want to provide the information about its spatial reference. So we want to expand data management tools here, and we actually want to go down to projections and transformations. And you'll see there are a bunch of subcategories here, and I'll expand this out a little bit. One is define projection. Now that's the one we want to use here, but if you notice, there's also project and create spatial reference. These are some tools that I'll overview in other how-tos as we need them, but for today, at least for this how-to, we'll just use the define projection tool. Now what you want to do is make sure that the data layer, the data set, or sometimes they're called feature classes, that just means that it's a vector data layer, there in this list, you want to make sure you pick the one that you want to add the spatial reference information to. The second part of what you have to do is actually choose the coordinate system. And luckily, and to get into that dialog box, you actually just click this button. And luckily, the folks at ESRI, the company that makes this, have predefined the most common coordinate systems for you. Now, let's say that you have a coordinate system. You know that all your data is in the same coordinate system, but it just turns out that one layer doesn't have the right one. You can use, or it doesn't have that information defined. You can use the import button here, and what it does is it imports the coordinate system from a data set that already has it selected, or already has it defined. So if we did that, it would, if we import it from another one, it automatically fills out this details box. But as it turns out, maybe we don't have any other data layers that have the right projection, so we have to select one that's already been defined for us. And when you click that select button, it brings up a menu, or an open file dialog box kind of, and there's two major categories. One is geographic coordinate systems, and unless you're making a map that's like continental in scale, you shouldn't worry about that category. The other one is projected coordinate systems. So when you double click on it, it comes into a list here. The ones that we're typically going to deal with in maps for this course will be state systems, UTM, national grids, or world. Okay. Once in a while, county systems, but since we don't live in either of those states, and probably won't be making maps of any of them, don't worry about it. Also, continental ones can come in handy. There are a bunch for North America, for instance. We'll leave those alone for now. Now remember, Universal Transverse Mercator is abbreviated UTM, and we are dealing with a data set here that has the North American datum of 1983. Now remember, where do I get this data? Hopefully it's already attached to that data set and I don't have to do any of this, but if it's not, I can usually find it in the metadata or on the website I downloaded it from. So I'll go in and I'll find this, and if you remember from the metadata, let's go back and look at that. What's the zone number? It's 16. So we'll go back here to the define projection dialog box, and we want to find zone 16. Now, luckily, all of these, notice all of these have an N attached to them. Well, that's because the UTM system is divided in between North America and South, north of the equator and south of the equator. And so when you go into NAD, North American datum, it's only places in North America, so they're all north. But if we had a different datum going on here, the WGS 1984 one, for instance, it turns out that there's a zone 16 north and a zone 16 south, right? So we'd always want to pick zone 16 north if we're dealing with the area that's north of the equator. Otherwise, it's going to put Indiana in the southern part of, south of the equator, and our other data will be north of the equator, and things will be all messed up. So we select 16 north, NAD 1983, UTM, click add, and OK, and OK. And just like that, it's done. And now this data will line up perfectly with other data. I just replicated the data set, but for instance, we can put on something like interstates, and it should line up properly. And then, which of course it is not right now. This is another. Okay, here's a perfect example. Here's another place where data spatial reference information, when it's not correct, will get you into a screwed up situation. This should overlay on this, and it turns out it's because Interstate's Tiger doesn't have the correct spatial reference information. So sometimes you'll get into a situation where you actually have to define spatial reference information for multiple layers before you can use them properly. But luckily for us, this CO18 layer here does have the correct spatial reference information now, since we've defined it. And if we had other layers that had that defined correctly, it should line up perfectly. So that's how you define a coordinate system and spatial reference information for a layer that's lacking it. Now there are other transformations you can do that give a layer a new coordinate system and spatial reference, but that's a different process and one that's covered in a different how-to. Anyway, good luck with this, and hopefully you don't have to do it.